So this one is from the 2010 AP exam. So Google 2010 scoring guidelines question 1. If you want to read this one on your own in more detail. I chose this one even though it was somewhat basic for Unit 3 and Unit 2 because it included Unit 3 and Unit 2. There's a very good chance that both questions on your AP exam this year will be multi-unit, so it's going to include topics from more than one unit throughout the year. It's not guaranteed, but there's a very good chance that they both will. So I just wanted you to get an idea of what it could look like. I think there would be more regression stuff with it if it was a question like this, but you could see a question like this mixing multiple units, such as this one right here. Okay, the first part asked you to figure out what the treatments, the experimental units, and the response was. My treatments were the concentrations of garlic, 0%, 2%, 10%, 25, and 50. Experimental units were the 40 birds, each in their own cage. The response is the number of food granules consumed by the bird. Part A scoring, essentially correct if the student correctly identified all 3 subparts. Partially correct if they did 2 of the 3, incorrect otherwise. Notes in subpart II, it is acceptable to identify the experimental units as the cages. So if you said the 40 birds or the 40 cages, you don't have to have the number, but birds or cages are both acceptable. And then in part 3, it is not correct to identify the response as the mean number of granules. So I know some people probably did that. They wrote the word mean because it said mean here. Overall, we find the mean, but individually, what we're calculating for each of the experimental units is just how many food granules were consumed. So the response is what you're measuring individually. Overall, we're looking at the mean, but individually, the mean should not be there. It doesn't specify here, but also make sure with the treatments that you specify that they're different concentrations of garlic. I wouldn't just write garlic. You need to be more specific than that. They didn't take off here, but they very well could. So you need to specify that it's different concentrations of garlic or specify what the different concentrations are. But you don't have to take off for this one. For the next part, you could have done either a scatter plot or a residual plot. I would recommend a scatter plot because it's way easier to make than a residual plot. Make sure you have a title, make sure you have labels on both axes, and make sure you went up by scale. Here I went up by 5 for every other line. Some people go 0 to 10, 25, 50. That is not a proper scale, and that will make your graph appear linear if you do that. That would be bad. Let's see what it says. Essentially correct, the student produces a correct graph and then concludes based on one or more features of the graph that the pattern of the relationship does not appear linear. So I did that down here. No, because there's a very clear curve in the graph implying a nonlinear relationship. Partially correct if they produce a correctly shaped graph but concludes the data are linear, or if the student produces an incorrectly shaped graph but makes a reasonable conclusion based on one or more features of the graph. Stop. No. Incorrect if the student does not include a graph, or if the student produces an incorrect graph and does not make a reasonable conclusion based off one or more features of the graph. Note any of the following would result in an incorrect graph. An incorrect scale. So if you did not properly go up by a constant amount on either side, that would be, well, that would mean your graph's incorrect. If you reversed your axes, so if you switched these, that would be partially correct, assuming your answer was correct here. Missing labels. So if I didn't label my X and Y axis, I would not have gotten credit for my graph. Or if you did another type of graph, such as a histogram or bar graph, that would not be good at all. I don't even know if you can get credit here. I can't imagine there's a reasonable conclusion you can make with one of those graphs. Okay, so that's essentially correct. So that E is on both parts. Both parts E is a 4 out of 4. EP is a 3 out of 4. EI or PP is a 2 out of 4. 1P and 1I is a 1 out of 4.